become available. Now, the heart of Hadoop. Why Hadoop is in market? Why Hadoop is that much powerful? Why everybody is talking about big data and Hadoop? The reason is map reduce. The reason is map reduce. What is map reduce? Actually, guys, the person who are the quite for a long time, some of you are doing coding in Java. So in the map reduce, you do coding in Java, but in map reduce fashion. It's not like that much conventional, because till now you were doing the coding that was running on a single machine. Now you need to think in terms that your code will run parallelly over a cluster of, say, might be hundreds or thousands of the machines. Your code will be running over all the machines parallelly. So that's why it's a little bit complex, and every function, every part of MapReduce itself is a little complicated. So try to understand everything quite clearly, and if you have any issues, just immediately ping me. I'll unmute you and you can ask the question. So MapReduce is a programming model designed for processing large volume of data in parallel by dividing the work into set of independent tasks. MapReduce is a paradigm for distributed processing of large data set over a cluster of nodes. So even the first line I would like to again explain. Processing large volume of data in parallel by dividing the work into set of independent tasks. Let's again go to our architecture diagram. So the work is submitted by the client, and MapReduce divide the work into set of independent tasks. So this independent task will be running by slaves, all the slaves. Client submit the algorithm, client submit the work, client submit the job. These are the three terminologies. And the master in turn submit that algorithm to all the slaves. So every slave, we are running one task. So here it is processing some data, here it is processing some data, here it is processing some data. So earlier I told you, if you can recall, the power to the MapReduce is given by the HDFS, design of the HDFS. Since HDFS is distributed, HDFS stores some data of the same file here, some data here, some data here, some data here. So say suppose block 157 is here. So block 157 is processed on the slave 1. If block 10, 15, 20 is here, it will be processed here. If block say 21, 22, 23 is here, so it will process on the slave 3. So whatever block is present, whatever data is present on whichever slave, it will be processed on the same slave. So the mechanism, the typical concept which I tried to explain you is called data locality. Let me type. One more question, one more theory question for you, assignment for you. What is data locality? This is a very innovative principle that comes with Hadoop. I'm trying to explain you, but also then do some Googling. So this is the third assignment I have given to you for today. Let's firstly talk about the conventional system. Say for example, if you submit any question, just a second, Prince. If you submit any algorithm, to your master or any of your machine, and if data is present on some other machine, so in the conventional methodology, conventional system, your data need to travel. Your data need to travel to the machine where you submitted the algorithm. But in Hadoop, the data movement is not there. This is one of the most innovative, and I love this principle of Hadoop, because currently we are talking data in the range of terabytes, petabytes, zettabytes. So movement of these petabytes of data is not at all acceptable. You can imagine the amount of time the data movement will take. It will take huge amount of time to data flow from one machine to another machine. So Hadoop's principle, you can note down this. Hadoop's principle is that instead of moving data, move algorithm or move computation close to the data. How exactly it happens? It's like when client is submitting any algorithm, so this algorithm will travel from master to all the slaves. Say for example, slave 1, 2, 3, 4 till slave 100. So to all slaves, whichever is having the data, client will submit the algorithm. So algorithm will go from here to here. Algorithm will go from here to here. You can imagine this algorithm is of hardly few KBs, 10, 20, 100 KB hardly. So this 100 KB algorithm can easily travel over the network and go to all the slaves. Now this algorithm will go say on slave 1, and this algorithm will start running here. This algorithm will process the data that is available on that slave only. This algorithm will process the data that is available on the slave 1. The algorithm which is going to slave 2, the same algorithm, and it is processing the data that is available on slave 2 only, and so on. So this typical principle is called data locality. Please note down this. Instead of moving the data, move computation close to the data. Is it clear? Prince is having some question. Yes, Prince, please ask.
So Anish, we just learned that HDFS maintain 3 copies of same data across the slave. Now, when we submit a job from master to slaves, let's say block slave 1 is having block 1, block 2, block 3, and slave 2 is again having a copy 1, 2, 3, and slave 3 is again having a copy 1, 2, 3. Now, when the job is submitted from master to slave, a similar job is run across these 3 slaves, right?
Yes.
So, when the slave 1 picks up those 3 blocks, 1, 2, 3, how does it stops other 2 slaves from picking up the same information which the slaves has already picked up?
Very good question. Appreciable. Again, actually master doesn't just send the algorithm here and just doesn't tell it that okay, go and process whatever blocks are here. Master will coordinate with the slave, and here the algorithm will start, and master itself will tell it that boss, you need to process these blocks. Master will say, suppose here you need to process block first and 3, and here you need to process block second. So all this decision is taken care by the master. So master define it, okay, you need to go here and process the block and then return the result. And on what factors it depends? It depends on few factors. That is, suppose if I'm having 100 block on slave 1, 50 on slave 2, but on slave 1 I'm having a very huge load. All other machines are some other job is already running there, because multiple user can submit multiple algorithms parallelly. So if the slave is highly occupied, the block will be taken from other slaves also. Prince?
Yeah.
Clear?
I still have a doubt. I mean,
Yeah.
let's say slave 1 has picked up first, second, and third block.
No. It's not like that. It's not like that. Slave 1 doesn't directly pick up the block. Master is having the block level information also, right? So master will tell.
So,
Master will
what I
coordinate.
understand is, yeah. So what I understand is, whenever any slave picks up any of the blocks, it immediately return back some sort of information back to the master that I have picked up this much information from that particular slave which was available in that.
No. It's other way. It's other way. It's master that tells the slave process this block.
Okay.
Okay.
So the
master knows,
information is distributed in a yeah. So the I mean information is distributed in a such a way from a master that information being picked up in a slave 1 is not picked up by any other slaves until and unless there is some
issues,
hardware failure or so.
Yes, some failure. Yes, exactly. So it's like if I again generalize the same thing what Prince told. Master submit the algorithm to all the slaves. Master also tell which block to process by the slave in very simple form. Okay.
Yeah.
Perfect. There's one more question from Ahmad. Is data locality done automatically by the master or we have to configure? Ahmad, it's automatically done by the Hadoop. So guys, this is about the exact flow of our MapReduce job. The client submit the algorithm and algorithm will travels to the slave. Now the data that is available on the slave, surely master will tell it that you need to process this data and the blocks getting processed parallelly or all the machines. So you can imagine this with the help of your HDFS, which is distributed. So your MapReduce is also distributed, and that's why it's achieving the distributed computing, parallel processing, and it will process all the data. And this is called a map phase, the first phase. In the MapReduce there are two phases. First phase is map, second is reduce. We'll come it to later in the next session. So then in this way the things are written and things are going ahead. So that's very basic overview about the MapReduce. Let me go ahead. We have seen this. This is for MapReduce. Now guys, these are the Hadoop daemons. Name node, a secondary name node, job track,